GIL behavior in Python 3.7 multithreading. I am researching and trying to understand the Python GIL and best practices to use multithreading in Python. I found this presentation and this video. I tried to reproduce the strange and crazy problems mentioned in the first 4 slides of the presentation. This problem also mentioned by the lecturer in the video first 4 minutes. I wrote this simple code to reproduce the problem. But the results are completely different from the paper and video. Executing time with threading and without threading are almost the same. Sometimes one of both case is a bit faster than the other. Here is a result I got using Python 3.7.3 under Windows 10 using a multi-core architecture processor. Also, what I understand according to the video and the paper is GIL prevent real parallel execution of 2 thread at the same time in 2 core. So if this is true, why the final count variable, in multithreading case, is not 0 as expected and will be a different number at the end of each execution, probably because of manipulation of threads at the same time? Does anything changes happen to GIL in newer Pythons than the video and the paper which use Python 3.2, cause these different? Thanks in advance.
Python is not executed directly. It is first compiled into so-called Python bytecode. This bytecode is similar in its idea to raw assembly. The bytecode is executed. What GIL does, it doesn't allow 2 bytecode instructions to run in parallel. Although some operations, for example IO, do release the GIL internally to allow real concurrency when it can be proved that it cannot break anything. Now all you have to know is that count equals 1 does not compile into a single bytecode instruction. It actually compiles into 4 instructions. Which roughly means each of these instructions is atomic, but the order can be mixed by threads, and that's why you see what you see. So what GIL does, it makes the execution flow serial, meaning instructions happen one after another, nothing is parallel. So when you run multiple threads, in theory they will perform the same as single thread minus some time spent on so-called context switch. My tests in Python 3.6 confirm that the execution time is similar. However, in Python 2.7 my tests showed significant performance degradation with threads, about 1.5x. I don't know the reason for this. Something other than GIL has to happen in the background.
Regarding Solomon's comment, the reason the code you wrote gives inconsistent results is that Python does not have atomic in-place operators. The GIL does protect Python's internals from getting mixed up, but your user code does still have to protect itself. If we take a look at your countdown function using the dis module, we can see where the failure can occur. The subtraction operation inside the loop actually takes 4 instructions to complete. If the thread is interrupted after 14 load_global1 count, but before the line 20 store_global1 count, some other thread could come in and modify count. Then when execution is passed back to the first thread, the previous value of count is used for the subtraction and the result writes over whatever modification the other thread made. Like Solomon, I'm not an expert on Python's low-level internals, but I do believe the GIL assures bytecode instructions are atomic, but not any further.
If you want to see more, please consider subscribing.